Hi, my name is Aditya and I am the CEO of Automaski. Today I am going to be talking to you about calculating the ground state energy using Universal Quantum Eigensolver, which is a quantum simulation system from Automatsky. Now, till now, we have shown you how you can calculate ground state energies using three methods other than this. The first method is variational quantum eigensolver, which is a hybrid quantum method where you have a parameterized circuit and a classical optimizer. Now, variational quantum eigensolver is okay for NIST devices, but it doesn't scale up for larger and more complex problems because it has a lot of issues. First issue is barren plateaus, because the optimizer gets stuck in barren plateaus where the derivative is literally zero, so it does not know what to do. Secondly, it is very difficult to make a good high quality ansatz which covers the entire solution space. Thirdly, the classical optimizer struggles with non-linear quantum solution spaces. The second option which we showed you is quantum phase estimation, which is a pure quantum method that can estimate the ground state energies of quantum systems. Now, that requires a literally perfect quantum computer, which we have, and hence it works for us. It might not work for anybody else for larger problems. The third way which everybody is trying to solve using quantum annealers is basically nearly impossible to do because quantum annealers don't have the full qubit fidelity. They just operate with spin up, spin down 0, 1 values or plus 1, minus 1 values. So we struggled for 2 years and then we figured out a way, and we showed you a demo where we have taken an open fermion molecule and we have used annealers to calculate the ground state energies. Now today we are going to show you universal quantum eigensolvers, which is basically done using quantum simulation. This is different from the quantum circuit simulators you must have heard about. That executes quantum circuits on classical hardware. This is not that. This quantum simulation is basically when a quantum system under our control simulates another quantum system of interest and does the Hamiltonian evolution and calculates the ground state energies. That is the only thing it can do. It cannot do optimization, it cannot run quantum circuits, it can only do Hamiltonian evolution. So that is what quantum simulation is all about. We have our system ready and it has been benchmarked today. We have 3 examples from the benchmark which I am going to show you. Now, we are the only company in the world which can now solve quantum chemistry, quantum materials and drug discovery problems at production scale. Using 4 of the methods we showed you, especially the universal quantum eigensolver which I am going to show you today, you can design batteries, you can do carbon capture, sequestration, nitrogen fixation for fertilizers, single atom catalysis, solar cell design, plastic pyrolysis, green hydrogen electrolyzers, air water pollution, catalysts, refrigeration, air conditioning, enzymes, drug discovery, clean energy, nuclear fusion, superalloys and superconductors. Now this opens up avenues for one thing which is very important, which is nuclear fusion. Nobody has been able to get nuclear fusion to work on a controlled, sustainable basis where the fusion reactor produces more energy than what is input to it in a sustained, economically viable fashion in the last 30, 40, 50 years of trying. This is because nobody understands how plasma behaves at 100 million degrees centigrade. And the only way to do is to solve that problem and successfully create nuclear fusion is by simulating plasma at 100 million degrees centigrade, ab initio, which is what we can do now with Automatsky systems. Now, I have a hydrogen molecule defined here. These are the operators. These are basically called qubit operators. This is the offset, this is the qubit operator. These are the Pauli matrices, I, X, Y, Z, etc. And these are the coefficients of the qubit operators. I load the SDK UQE SDK here and it is running on this IP address through our VPN to our data center and on this port. The number of steps and samples is mentioned here, and I call solve and I print the ground state energy. This is the alpha solver which solves for ground state energy. This another one, beta solver, is not ready yet. It can solve for ground state energy and also get you the quantum state. It will also return the quantum state, obviously by measurements and histograms and everything, but that is what it will do. So that will be available very soon in the next 3 to 4 weeks or maybe a month. So let's run this problem. You have seen this problem now. This is the hydrogen molecule Hamiltonian operator. So let's run this. Python h2.py. And there you have the ground state energy minus 1.836960487. Let us run the next problem, which is beryllium hydride. You can see the qubit operators here and the coefficients here. The same structure, I call the solver and get the ground state energy, and this is the beta solver. So we have tested our system for very large molecules for production grade chemistry applications. Here is the energy minus 2.637484, and this is the water molecule. Here are the qubit operators, and these are the coefficients. And I'm going to similarly run this. This is going to take a long time, but never mind, we'll wait for it. I will not stop the video so that you believe that the simulation is actually running. This should take 3 to 5 minutes because quantum simulation is adiabatic and so it takes a lot of time for the Hamiltonian evolution, etc. So our SDK is in Python, as you know that I'm running Python files, and you can integrate this within your quantum circuits. You can use the Open Fermion library to generate the qubit operators. You don't actually have to use any quantum frameworks from any vendor. You can simply use Open Fermion, generate the qubit operators and run it and calculate it. Open Fermion, etc. libraries have brute force solvers for small problems, but instead of using those you can use this, and this can be deployed readily. Our other 3 solutions, variational quantum eigensolver, quantum phase estimation, and annealers, are also available together. This is a very strong portfolio, and it solves quantum chemistry, quantum materials, and drug discovery absolutely. So this is production grade, and let us, I think it will take 1 more minute. This is a larger problem with 551 operators, so it is larger in size. Like I said, we have already benchmarked this against the other offerings from other vendors and etc. And so there are no technical risks. This is proven and this works today. Maybe another half a minute. So we are setting up quantum centers in the Middle East and in India, and this will be deployed there in the next 4 or 5 months. So it will be available even otherwise on the cloud also. Almost done. Yep, there it is. Ground state energy minus 23.5409. That's all we had to show you today. Quantum chemistry, quantum materials and drug discovery is a solved problem now. We can attack production use cases, and we can do things like catalysis, battery design, solar cell design, nitrogen fixation, carbon sequestration, nuclear fusion, etc. today. Let us know how we can help you. Contact us on info@automatski.com. Thank you very much.